Well, the other point here is that the arguments will be or usually used to be promoted or demoted. So it's like as we can see here. So for example, if you're actually promoting, like if you're passing the oh, let's just leave this kind of okay. So imagine that here you are passing 8 and you are reading the function as double num. So here you're actually promoting 8, which is actually an integer, or like it seems that like it's kind of an integer value because it doesn't include any floating point. It is usually promoted as double. So this is what it means by by double. I mean like by promoting or demoting value. Okay. So all right. So calling functions with multiple arguments. Here you can actually it doesn't calling the function or calling the the function here, it's not necessary to include only one. To include only one argument, but rather you can actually add as many arguments as you want. So how to decide this? The first thing here, because you see, whenever you are planning to write, whenever you are planning to develop or create a new function, you cannot actually start from the function call. Although the function call seems to be the first code, the first code related to the function that we are creating here, which usually used to be placed in the main. That happened to be the main, like the first part of the program to be executed. But I'm advising you here whenever you are using you are creating any new function, it is first to create the function header and define how many, for example, how many parameters do you want to use, because these parameters later on is not only used for just for the sake of listing, but rather you are actually defining the parameters here to be used within the within the program, within the function body itself. So let's say I'm defining like int num1 and int num2, for example, and also double here rate, double rate, let's say. Okay, so first I define the function header, deciding how many parameters, for example. So in this case, let's just go for example of 3 parameters, and then I display, I go to the function prototype here and modify this. So here, either modify or recreate the prototype. So here we agreed that we only need to use the list of parameter types. So the parameter data types here is int, and double, and they have to be in order. So int and and double here. Remember here, order is very important. So order here have to follow the same order in here. You cannot just mix up the order to be like a double in the middle or in the first. Okay. So remember, ordering here is very important. And then lately, later on, now you are ready to receive. You have created your function with the parameters which are ready to receive values. So here with this kind of calling, this is actually wrong. This kind of calling is wrong actually. Why? It is because it has only one arguments here. We remember that the number of arguments should match the number of parameters. So if we have 3 parameters here, we need to have 3 arguments that are being separated by commas here. Same for the parameters, they are being separated by commas. So, and also remember that the value of the arguments here, of course, they should match the data type of the newly created parameters here. So for example here, for example here I'm writing 2.5 to say. All right, so whenever you're displaying this, what is it? Okay, let me just comment this. Okay, so in order to having this to say that there is actually starting in the main. Okay, so all right, so here I'm just passing this passing here. What I'm doing is that I'm passing 3 arguments into passing 3 arguments to the function display value. Okay, so these arguments are like this. So if you executed the code here, you should actually have this has been displayed. So here, because of course we need to let me just modify this a little bit and have num equal to num, and then the value of like num2 should equal to num2. Okay, and see out, that should be equal to rate. And of course, we have to use typically the same names. Here doesn't matter because this one is just a user prompting message. You can say whatever like message you want to display, but important thing here, the variable name has to be typically the same. Okay, if you just misspell that, let's say for example writing number here, this is of course undefined variable. This would be treated as an undefined variable here. Okay, so we either have to like use the same variable name or use another variable like number, which is like before this we write number here equal to num and use num here as a variable. So here we use we use it as num. So in this case, if you display it out, you can see 8, 4.44 and 2.5 as you can see here. Okay, so this is very clearly and this is very easily can be done. And as I told you, remember this, so you need to remember the matching between the the prototype, the parameter list, and also the call, the function call. You should match the type of the variables here. Okay, let's say we are actually displaying a. Okay, so here what should be actually the change that we should modify or we should attempt here? It should be here. That has to be char. Okay, and doesn't matter, the name here can be any name you want, but let's just make it so near to be like a code, because this may represent like a little bit, this may be a little bit relevant to the value that should be received. And here we can use a code here. Okay, so if you display that, of course here has to be changed, don't forget this has to be changed into char, and then you can just display a as as has been displayed. All right, so order here is very important. So the number of argument here must match the function prototype and the definition. This is very important, and here the order is important here. So the first argument should go into the first parameter, the second argument should go into the second parameter, and so on and so forth, like this. So 8 will go into num, 4 will go into num2, and a will go into code. And here the display doesn't matter because this is up to the programmer himself. So he can even display like this to be in the beginning, or he can maybe display even this to be in like the in the very top also, because you see this is just the body of the program that can be customized as we want here. All right, so this doesn't really make really a critical importance. All right, so here this is exactly the same example that we have taken just now, and it actually explains that. All right, so there is another actually way of passing parameters here. So just now we were talking about like passing parameters by the value itself, meaning that we have to have a kind of literal or a constant value. What if I want to read a parameter using a value of x? I do not want to have this actually now. Let me just minimize the example to be as simple as that. And I want to read it by x. So here one may ask, so what is x? And to some of us, it may be kind of familiar. So I believe that x here should be kind of a variable. But here, as we have learned before, a variable have to be defined before it's used. So meaning that I have to define the variable here. So where should I define it? X here, it's a part of main. X here is a variable that should be defined within main. It doesn't belong to display value or whatever other function here. So meaning that, so this is actually a property of the main function. So we should define it as int x. Why int x here, not any other thing? And int x here it has also to have a variable. It has also to have a value, sorry. So we cannot say that int x without any value. This is actually will be wrong because, okay, so int x, so what is the value? Because at the end of the day, I'm passing a value here, okay? At the end of the day, I'm passing a value. And of course, this value have to have, the value here is carried on the, it is being returned from the variable name. So if the variable name doesn't have a value, then the value here will be null, okay? So here it will be null. So this is actually not really logical. So that's why we have to have the value that has been assigned. So we can write it like this, and we can now read the value of num here as 5. This is very simple, as you can see here. So x, So first, value has been assigned to x, and then x has been used as an argument here. X has been used as an argument. X is an argument. And then the value of x here has been received from the function that we are going to display to use here to create using a parameter, okay, that its name is num, and the type here, this is very important, that the type of that variable must be the same as the type of the variable that holds the value that we want to return. As long as x here is it's being used as an argument, so its type has to match the type of the num. We cannot actually say that this is double, define this as double, and we want to return this. This actually brings kind of an error, all right? So that's why here this has to be same as the value of the parameter that receiving the value. Okay, so passing value from, we can actually, this is the first type. The other, the other way, as you have learned before, we can define x and we can allow the user to enter value. So by cout, okay, enter x, for example, and then cn, what is x actually? This will decide, this will be decided by the user. And then, so whatever value has been defined by the user, it will be actually brought up here, and then it will be passed into the function. So this is it. So now we'll be prompted to enter value of x, for example, 66. So the num here is 66, of course, because you are passing the value and copying it the same. Okay. All right. So this is one point. The other point here is that I can actually modify that value. So if I type here num equal to num divided by 11, all right, and I want to display that, and I have said that, okay, so here cout, I want to activate this, the value of x, the value of x should be x. What do you think the output will be here? Well, the output will be the result of the updated number, since this has been updated in here. My answer here is no. It is that you need to know this is a rule now. So the rule says that the value of the if you are passing a value from a variable here, so its value that has been passed into the parameter, it will not be changed by updating the parameter. So whenever, doesn't matter whether we update this parameter or we have deleted this parameter or we deleted the value here, this doesn't change the value of x, the original value of x that has been defined. So let me just for now, let me just simplify this. I will just comment this out because I want to show you the clear image of the point that I'm clarifying here. So if we define this as 66, for example, okay, if we define a variable as 66 and we are passing it here, so now my point here says that no matter whether we updated this or whether we use this value of the num in any kind of formulation, this of course must not actually change the value, the original value of x that we have passed here. So the evidence here is that if we want to copy that value here, if we want to read that value here, it will not change its value. Let's just run this code and see. You can see that. So the hello from function main here, and then num here will be actually 6 because this is the second statement by executing the code here. Then compiler, after displaying this, has gone into the main, into the function and executed the code. So displaying the message num equal to, or num dot after the operating here. So 66 is divided by 11, which is the pass value, because the pass value here is 66, has been received using a num, and then so num will equal to 66 divided by 11 will be equal to 6. So that's why we have 6 here. And then after finishing the body, executing the body here, it returns back and executes the final, the final statements here. The value of x is x. So x here remains the same, 66. It doesn't change because actually only its value will be copied. It's not the value will be modified. So it's a copy. That's why we say a copy of that value will be passed into the parameter. It's not that the original value itself, it will be copied, meaning that whatever changes have happened here in the parameter should not affect the value, the original value that has been passed. It doesn't matter whether you're actually, assigning it constantly or you're even reading it from the user. So let me just show you this again. So even if the user have decided to enter, the value here, so x, for example, 55, or it's just 66. Type the same function here. So again, num is 6, of course, because num is being displaying from here, and then the value here is 66. So it remains as the same. All right. So this should be really, really kind of a good point for you to mind. Okay. So if you're actually displaying C out, num here before update is num. What do you think the output here? End line. What do you think the output should be here? So of course it should be typically same as x. Why? Because in this place num is not, hasn't yet been updated here. So if you executed this code, so you'll be having enter 6 here. Let's say 66 again. So the num before update is 66, and then num here is equal to 6 after updating, as you can see here, and then it returns again back to the main value, to the main function, and displaying this line of code, so displaying 66 again. See, so this one here is the original value this is a copy of the value. This is a modified copy of the value now. So num here, it can be printed in different with different values here. This is the original copy, which is that the one has been received from the parameter, which has been copying the value of the x that has been entered by the user, or can be, as we mentioned, can be assigned constantly. All right. So as you can read here, so passing by value here. Let's just go into the theory part. So when an argument is passed by value, a copy of its value, that's why we said a copy of its variable, of its value here, is placed into the parameter. So the function cannot access the original argument here, of course. So meaning that, the change of the variable here, whatever value that has been changed here, it cannot access the value of, let's just again assuming that this is actually 66. So meaning that this value, of course, shouldn't be changed. So changes to the parameter in the function do not affect the value of the argument in the calling function. So if this argument has happened to be 66, calling it from here, whether even if we are using it, if we are reading it from the variable, even if we are assigning it as a constant, okay. So a copy of this value will be here. So this, this function, or this kind of value, it will remain the same. It will not be changed. The only thing that will be changed here is the parameter. That's why, because the parameter here is copying that value. So typically this is what we are trying to explain here. So defining a value here, int x equal to 66, and then we are typing the value, the name of the variable that has the value. So here val will be 5, and then it will be returned as 5 here. Okay. So with that, and let me just actually at the end, before this is the end of actually our session, but let me just remind you, further give you an example, because we have just actually skipped the other type of function. If you remember here, you can see that all of our examples that we give is just on the non-returnable function. So one of you may ask, so what about the returnable function? We didn't practice about int. Int kind of function, double, whatever function. So how can we deal with them? For example, if you remember during the first, during the first part of this session, we were talking about, we give an example of int sum, for example, and then we open brackets, and then this is our function. Okay. So let's say that now we want to use and execute that kind of function. So within the function here, as we mentioned, so int type of function, of course, it has to return. So what it returns, we don't know yet. we have to decide this based on the whatever, like the purpose of this function. So if the purpose here is to calculate sum, of course here the return will be some variable that indicates the sum. For example here, let's say that we are displaying int total, int total here, and int y equal to 3, equal to 5. Okay, so we can say that total equal to y. This is a very, this is, I'm trying to do, I'm trying to execute a very simple adding operation. So y plus, for example, 4. Okay, as simple as this. And I'm going to, now I'm going to return, it depends. You can return any variable name. So the return here can be to the variable name or it can be to the, to a constant value. But of course, this is not practical because it never happened like before. So most of the practical returns, the returning values here, it happens to be like a variable name. So either y or a total. So because we are doing sum, we are creating this function for the sake of sum, calculating sum. Of course, the most reasonable return value from the variable total here. Okay, so we have created the function. Now we need to define it in the prototype, or we need to initial. We need to declare it in the prototype. So the declaration here happened to be like int sum and open close bracket. That's it. So this is it. We do not have any kind of variables inside. We do not have any parameters inside. That's why this is empty. This should be empty. All right. So here, let me just delete this and delete this again. Okay. So here, how can I execute it? It's by calling it. So calling it here, calling the function here. It is that now this function is being treated as a value. So depends on the return. Whatever we are returning here, it will be the value of the function. So we can assume this as a value. So that if we are calling the function, meaning that we are returning its value, we are returning its total here. Like for example, here you can see out the value of sum is just whatever message you are displaying here, and I want to call the function. Of course, calling function happened to be by its name. So here I'm just using the function name. Of course, whether you have space or not doesn't matter here. And end line. All right, so just execute this code and we can see the result here. And total. Oh, yeah, mistake. All right, so executing the function here. So the value of sum is 9, of course, 4 plus 5, 5 plus 4, so returning total. And that's why you can see here the C out. So that's why this is the only C out. And if let's say we didn't have this, okay, and we want to execute, we have nothing here. Why? It's because this function doesn't include any C out. Even if we have C out here inside C out, let's say total. That's it, like that. So if we see out here, we have nothing. Why? It's because the function has not been called. Okay, even if we call the function like this. Okay, so that's why the function here actually can be, it has to be called in order to be passed. In order to be executed. So here, if you executed that, the sum is 99. So why is that happening? It's because actually it's been executing the total, which is the internal, comment. That's why. But most practices here, it's that this kind of function is used to calculate something and then return a value. It doesn't actually include any kind of. It may actually ask the user to enter a value. It could be like C out. It could be like handling something like C out. Enter a value of, for example, y. This has to be indicated in brackets, and even this entire statement to be moved here. let's say that. So here, and then see n y. So it can include actually that kind of, I mean, like that kind of code. It doesn't matter because you see the function here, it's just a block of code. It can include any kind of code. So if you just click here, so enter the, of course, so this is the point here. So thing is that we need to have that kind of code is manageable. All right. So in order to execute this function, you can just simply display it out like this. Okay. So by having it like this, enter value of y, 8, that will be actually 12. All right, so, but this is actually kind of detailed, more detailed thing. We are just trying to simplify and, I mean, like illustrate what is the value of, I mean, like how to handle the kind of returnable function. All right, so, all right, so what if, I mean, like, is it like total is the only variable that can be called? What about is the only variable I mean to be returned? If we return y itself, can this be done? So if we executed this variable, this program, you can see here we can have like whatever depends. So the value of that function depends on its return. Whatever return value, it will be displayed in here. Okay, you can also actually assign this to be like int y equal to sum, for example, and actually can here use y. So we can handle this as a variable. So it seems that this is a value. Okay, so y will be equal to the execution of the function here. The execution of this function, it's actually the return value. It returns the value of y, or the value of total here. And once you execute that, of course you should have 9. Okay, and then you can here even type this as you can see here. So this means that this, I mean, like the value of this function execution will be copied here into that variable, and then the variable will be returned, and the value of this variable will be returned here. Okay, so actually this is, I'm like more into practical session, of course, will be exposed to you. I'm trying just to like open your eyes into all the aspects of the implementations in the theory to say regarding the function. And this is of course an introductory level of functions. Of course there are very much deep details about the functions that you can study beyond this course level. But with that, let me just thank you for watching, and I hope if you have any question, please just don't hesitate to I mean like to consult and ask with me. Thank you for that, and see you later.